Hello everyone. As we were discussing about the geotechnical engineering, a part of that has been already completed by us. Now let's move to the next part, that is the index properties of the soil. Okay. Index properties of soil. Now what is this index properties? First of all, we have to understand this. Index properties means the properties which actually influence the parameters or the functions or the behavior of the soil. Okay. So, we will be discussing the important index properties in details with their physical, and also we will also be incurring the practical of those index properties, means how we will be finding them practically in lab or in field. Okay. Let us continue now. Determination of index properties of soil. Okay. Let us see those properties of the soil which are used in the identification and classification of the soil are known as index properties. What does this mean? Means if a soil is given to us and we are to classify or see which soil is it or what kind of soil it is, then what we will do? What we will check into that soil or how we will classify? We will first of all see the water content, density of the soil, specific gravity, particle size, consistency, density index. Okay. These all are the index properties. We can classify those soils according to water content as well, okay, according to the density, according to specific gravity, according to particle size. How? Example, if we talk about density. Now, in situ density we are talking about. Okay. So, what is in situ density? In situ density means the density of the soil in situ. What is the word in situ? In situ means in situ. The word in situ means is actually the in the field itself, or in the place where the work is being carried out. Okay, not in the lab, in the field. It's called talking about the field. So, in the field we will see the density of a soil. If it is highly densed, okay, highly compacted soil, it may be a compacted soil, okay, or it may be a loose soil as well. So, this is a type of classification for the soil. How is it done? It is done on the basis of density, okay, compactness. Similarly, there are, suppose the particle size. What is particle size? This I think you already know that they are fine grained soil, again coarse grained soil, okay, and again medium and all. So, this is also a classification basis. So, all of them are the classification basis for the soil. We will be seeing them one by one. So, let us move forward. The methods of water content. The first was the water content. So, we will be discussing about the water content determination. I think you already remember what is water content. Water content in general, if we see, that is represented by small w, is W upon Ws into 100 is also applied if it is for percentage basis. Okay, this is the formula for water content. Now, in the water content, this is the formula only, and if we are to find this in the field or in the lab, then how we will do it? Okay. So, for that there are a number of methods. You can see there are many methods. The most popular one are the oven drying method, okay, and also the picnometer method. What is oven drying method? What is picnometer? We will be discussing it in the forthcoming slides. Okay. Suppose this calcium carbide method, you need not remember everything about this, but you must remember that it is the quickest method to find water content. It is the quickest method to find the water content. Okay. So, what happens in this is, I will just tell you briefly what happens. We take, there is a moisture meter, it is called a moisture meter. There is a device in which the soil is poured, moist soil is poured. This is a device, okay. It is also called moisture meter. what happens is the moist soil is not dry soil, remember, because we have to find out the water content. If you pour the dry soil, then that will be of no use. So, water content is to be found. So, moist soil is put into the device. Then what happens? The lid is closed. Okay, the lid is closed. After that, also before this closing the lid, we add calcium carbide to it. What is calcium carbide? CaC2. Okay, this is added to this. Added to this. Okay, so when this the moisture in the soil will react with this to form the moisture in the soil will react with calcium carbide to give, what will it give? It will produce a gas which you might have heard, acetylene gas. Okay, acetylene gas. So, this plus this will give you acetylene gas. Now, this gas will produce, as it is a moisture meter device, so it is calibrated or made in such a way that once the gas is produced in the container, it will exert pressure. You know that filled, if a gas is produced, then it will have a higher volume. So, there will be a pressure exerted on this container. This pressure measured in direct terms of moisture content, means how much pressure is being exerted on the walls or on the device is directly calibrated in such a way that it will give you directly the value of W. Okay. This is the first method. Now, also there are nuclear probe method. In this, there is a generally for field it is used. There is a tube here and here, tube is here. This is the soil itself. Okay, a probe, a nuclear active probe is here and here. Then from here it is released. Nucleus is released and it is received here. It is a receiver here. Okay, so this will be going through this and receiving will be done here. If there is moisture in the soil, it will lose its energy. This neutron or whatever it is discharge will lose its energy while going through this path and reaching here. So, we know what energy it should have and what is being achieved here. So, finally, we can say that the amount of energy lost will finally tell us what? The moisture content. This is the nuclear probe method. Okay. Then the alcohol method is also there and others are also there. So, these are not so important. Let us now discuss the important ones. Let us move further. Oven drying method. This is the most general and most used method for determining the water content. What is it? Let us see. The oven drying method is widely used laboratory method to determine the water content or moisture content of the given soil sample. It gives very accurate results. Okay. Why it gives accurate result? Because in it it is done in the lab, as you have seen. It is done in lab and it under controlled condition. Whenever anything is done under controlled condition and with great precision, it will give us accurate result. Okay. So, it is actually a laboratory method. In field you cannot do it, because for this you have seen it is oven drying. How can you get an oven in the field? So, it is a laboratory method. What are the apparatus used? These are the main, obviously the oven. Okay, non-corrodable airtight containers, 3 in numbers, means you can see the diagram here. These are there are many numbers shown, but generally we require only the 3 numbers of airtight. Why airtight containers? Because so that the moisture does not leak out. Okay. So, just what we do, we will be, this is with lid, we will open the lid and put the moist soil inside it, then put it inside this. This is the oven. Okay. This one is the oven. From we take the moist soil and do it and put it inside this and put it inside this. So, for nearly 24 hours. We will discuss it in detail later on, do not worry. For the timing, let us see the apparatus first of all. Digital weighing machine, these are also shown there. This is the digital weighing machine, okay, for weighting the mass of the soil. and desiccator and tongs are also used, but the main are these three. Okay, this I have already told you what are these. Okay, these are the equipments required. And this is the desiccator. Okay, now the test procedure. Let's see how is it done in the lab. First of all, first step, clean and dry the containers and weigh them and note down the mass of each container M1. Also note down the number of each container along with its weight. Okay, what does this mean? What happens is you have three containers. Okay, this is a container, you have three containers. It is numbered. Okay, at the bottom, if it is the bottom part, we number it 1, the second one 2, third one 3. Okay, so that we can identify. Now what happens? First of all, we take the soil. Okay, first of all, let finish this process. What we do? First of all, we clean it. Okay, make it clean and dry. Okay, then what we do? We use the weighing machine to weigh their own weight. Means the weight of the container itself when it is empty. Okay, so first of all, the empty container is weighed. After that, what we do? It is named as M1, mass of the empty containers. Okay, along with their number. Means suppose the first one is 5 grams, second one is 3 grams, and all. It is also something like x grams. Okay, so we corresponding to the number of the container, we write their weights. Okay, after that, what we do? Collect the soil sample from field, remove the top layer of the soil and collect the wet soil bottom layers. Means take the soil from the field, come to your lab. After that, remove the top layer of the soil and get the moist soil, because the top layer may not be moist, or maybe it may be having some foreign other moistures also. So we don't consider the top layer. Okay, this is the top layer of the soil. We go down and somewhere here, from this part of, we take out the soil for the experiment. Okay, we take the soil from this part for the experiment. Now what we do? We first of all, we have collected it, okay, from the bottom. Now fill the containers with the required quantity of the soil sample and weigh the each containers and note down its mass. Means now we have the soil. Okay, you can, what we can do, that divide it in 3 parts. Okay, means it need not be the equal parts, it can be anything, some maybe 10 gram, 5 gram, 3 grams, anything may be there. After that, after dividing the soils, one part of this soil will be put in first, second in the second, and third in the third. Okay, and we already have their own empty masses as well. So what we now do? We now weigh them again with the moist soil. Now this time we will be doing it with the moist soil, and this will be named as M2. Okay, this will be named as M2 this time. So what happens? This is put in this, and now for corresponding one, we will have for empty and for filled. Okay, 2 parameters we already have found, for 2 as well and 3 as well. Now let's see. Place the containers in hot air oven, okay, for the temperature of 110 plus minus 5 degrees centigrade. Allow them to dry for 24. Why is it used only 110 and 5 degrees centigrade? Because if we increase above this temperature, then the, if you remember, I told you about the structural water content last time. So if we increase the temperature above this, okay, if we improve the above increase the temperature above this, then structural water will also get released, due to which what will happen? The mass of the soil will differ from the actual, and water content which actually was to be met will be different. So it will cause an error. So we have to maintain the temperature only inside this. Then again, as I told you, it will be kept for 24 hours. Then turn off the oven and take out the containers using tongs. Now the tong is being used here. Cool down the containers in the desiccator for 1 hour. After that, weigh the containers and note down the masses, that is your M3 now. Okay, find the moisture content using the above data. What will happen? Now you already had for one empty and filled with soil of moist soil, I must say. Again, after putting it in for 24 hours in the oven, what will happen? Again we have to measure it. Okay, now again it is filled, but now this is not moistened, now this is dry soil. okay, oven dried soil. So we have three things now. So this was named M1, this was named M2, this was now named as M3. Okay. So now these all data we are having. So how we will finally calculate the water content? See, this is the formula: M2 minus M3 upon M3 minus M1 into 100. What is M1? Mass of empty, as I already told you. This is with the wet soil, okay, M2, and this is with the dry soil, M3. Just put in this and we will get the water content. So this was the total laboratory experiment we use for the oven drying method, okay, to find the moisture content. Now let us move to Picnometer method. What is Picnometer actually? It is also a container, okay, it is something like this, okay. It is a steel cap here or brass cap here, and this is of generally of glass. You can see the diagram. I think we have this is the Picnometer, okay. This one is the Picnometer. So let's see what is this. Picnometer method is also useful to determine the water content, but this is used when the specific gravity of the given soil sample is already known. Okay, specific gravity can also be determined using Picnometer method. This part we will be doing in the next class, where we will find out the specific gravity using Picnometer method. And what are the apparatus used? Picnometer, obviously, weighing balance with accuracy, and glass rod and vacuum pump. This much things are required for you doing this. Why do we use vacuum pump? When we pour the, let us first go to the procedure, you will understand better. What is done? See, first of all, wash, clean and dry the Picnometer and note down its mass M1 along with the brass cap, okay, and washers using weighing balance with an accuracy of 1 meter. This is okay, but first of all we have to weigh the Picnometer in the dry condition, okay, along with the cap. That will give you the M1. Then place the sample of wet soil, okay, about 200 to 400 gram in the Picnometer and note down its mass M2. What is M2 now? First one was the empty, remember. Now this is having the soil, that too moist soil. So this will give you M2, okay, this will give you the M2, moist soil. Then add water to the soil in the Picnometer to make it half full. Means what now? What we do now? It's having soil. Next, in the next part we do is, in the Picnometer itself there are soil solids, okay. These are soil solids. Fill it with water. Fully fill it with water. The remaining part, which means the soil was there already, the remaining part of the Picnometer is to be filled with water, okay. Is it okay? Now stir the soil using glass rod to remove air voids of the soil. If the available connect the vacuum pump to the soil specimen to remove the entrapped air. Now you understand why vacuum pump is used, okay. This is used to remove the entrapped air. Both the glass rod and the vacuum pump have the only one reason of using, that is your remove the entrapped air, okay. So we will be removing in air. Why? Because if the air is there, then it will become the source of error. So after that, what happens? Add some more water, and after eliminating the entrapped air, stop stirring and fix the brass cap. More water is added through the hole in the brass cap until the water is flush with the hole. Means there were, what was there? It was M3. It was M3 with water and all, but we have to remove the, what we have to remove? We have to remove the air voids from this. So we use the vacuum pump or we use the glass rod to stir it. Once the air voids are removed, means there is some part remaining that is empty, that part should be filled with water again, okay. We have to fill the water again, so that up to the full level or till the water comes out, oozes out, we have to fill the water. Now it means that fully the water is there filled, okay. This now will give you the M3, okay. Now empty and wash the Picnometer, okay. Again fill it with water. Now again fill it with water, wash it properly. Now again fill this picnometer with water only. This time there will be no soil, only water, only water. This will give you M4. Okay. This whole process is to be done, means we have now 4 mass, M1, M2, M3, M4. We have 4 masses. Then we will use the formula. Okay, I think it skipped here. What will be the formula that we will be using to get the water content? It will simply be M2 minus M1 upon M2 minus M1 plus 1 second, M2 minus M1 upon, sorry, I think it's error. This as well. This will be M1 minus M2 upon M1 minus M2 plus M3 minus M4. Okay, this will be the formula that will give you the answer. This is 1 second. Plus. Okay, this will be the final formula. So we will get the water content from picnometer method. Now sand bath method. This is not of much use. This is used as the field method. But the problem is what we do. We use a stove or kerosene stove. And what we do, just let me read it out. Rough value of water content. This the container with the soil is placed on the sand bath and heated. Kerosene stove. The soil become dry within half to 1 hour. Okay, it should not be used for the organic soil or soil containing high percentage of gypsum. What does this mean? Actually, what we do in the field, we use the stove. Okay, let me say this is a stove, suppose. Okay, so we will use a sand bath, means filled with sand, or container filled with, and on it we will put the container having the soil. Then we will let it. This is something like this stove. Okay, so this will we will heat it for half to 1 hour until this is totally dry. Then we will weigh it. Weigh first before putting it here, and after, then the difference will give you obviously the water content. Okay, but this method is never used for organic soil and soil containing gypsum. Why? Because in organic soil, if we use this, then oxidation will occur. For this, oxidation will occur. Oxidation. Okay, and why for this? Because structural water will lose, because you know that it is not a controllable process. It is not that it will be only from 100 to 105 or 110 as I told you before. So this is not used where gypsum is there. So this was it. We have covered the water content part only for the time being. Okay, so here are some questions you can find out, the water content process and open drying method. Later you have seen in the first slide there were a number of index properties. So the other index properties will be slowly discussed in the forthcoming classes. Okay, next time we will be discussing specific gravity, dry density. Okay, keep watching the videos. Thank you.